Hi everyone, in today's lecture we'll try to cover the concept of RC series circuit during the charging phase and the discharging phase. Let's start with this application. It's available on your book, number 5, Energy Transformation in a Series RC Circuit. As you can see here in the circuit, the switch is under two choices. The first one, number 1, showing the battery in series with the capacitor and in series with the resistor. And under the second choice number 2, it's just the connection between a capacitor and a resistor. And it's clear for the first switch number 1, once it's turned to switch number 1, the phase will be charging phase, and under switch number 2 it's going to be discharging phase. They said that a resistor of resistance R, a capacitance, initially neutral, so it's uncharged at t equals 0. Of capacitance C, a battery of electromotive force E equal 80 volts, and of negligible resistance, internal resistance. An SPDT switch and connecting wires. So here we'll try to cover the concept of charging process in the first part and discharging process in the second part. Okay, let's note that the meaning of SPDT is that single pole double throw switch. So here we have a single pole and here we have double throw location for the switch to take into consideration the first current and the second way for the current. So in the first part, part A, indicate the direction of the current I in the circuit. We are taking the first position for the switch, which is number 1, at t equals 0. So the current will be flowing from the battery from the positive pole out to point M, A, B, D, and then to point N and back to the battery. So it's going to be rotating in an anti-clockwise direction. So capital A and small a, and the answer is counterclockwise direction. This is the direction of the current. Let's move to part B. In part B they said determine the expression of the current I in terms of E, R, and the voltage across the capacitor UC or UAB. Let's start with the law of addition of voltages with this circuit. So we can just write UMN starting from the battery equal UMA plus UAB. This is the one mentioned here, named as UC, plus UBD plus UDN. Note that we must start with the first letter and end up with the last letter. Similarly here, we start with the first and we end up with the last. MA is a wire, connecting wire, 0 volt. DN is a connecting wire, 0 volt. Once the switch is closed, it acts like a connecting wire. So we still have UC, so this is U generator. We can directly take into the symbol given, which is E. UAB is UC, and this is U across the resistor, which is capital R multiplied by I. So this one is named as capital E, electromotive force. This is UC, and the voltage across the resistor we just multiply R by I, Ohm's law. Now we can just go and write the expression of the current I using this formula, I equal E minus UC over R. This is the second part, part B. Let's move now to part C. They said in part C, at t equals 0, the value of the current flowing in the circuit is 80 milliamp. Deduce the value of R. So the current flowing in the circuit, we can just write the value of the current as I equal 80 milliampere, and this is the given value, and they said that we must deduce the value of R at t equals 0. So all of this will be at t0 equals 0. Note that at t0 equals 0, the capacitor is uncharged, so it's still neutral. So U across the capacitor will be 0 initially. We must seek to find the value of R equal question mark. Directly we can use the previous answer. So from this answer we can go and search for the values. Let's directly put the values here. So 80, I'm going to use it in the SI unit, times 10 to the power minus 3 ampere equal E. Let's check the value of E within the given. It's 80 volt, so equal 80 minus 0 over R implies that R equals 80 over 80 times 10 to the power minus 3. This will cancel and the final result will be 1000. Don't forget the SI unit for resistance, it's ohm. This is part C. The final part for section A: indicate the components that supply electric energy to the circuit and those receive electric energy during the charging phase. It's clear that the generator is providing energy, supplying energy to the resistor and the capacitor, while the resistor and the capacitor, they are just receiving this energy from the generator. That's the last part number D. Now we'll start with the second part, which is the discharging process. The switch is turned to position number 2 at an instant taken as a new initial time t0. So now this switch is turned into position number 2. The fully charged capacitor discharges through the resistor at t equal 2 seconds. The voltage you see across the capacitor becomes 0.37 E. So as you can see directly from the shape or from the given 0.37 E, this time represents 1 tau. Since we said during the lectures, after 1 tau the capacitor will be discharged by 63%, or it's charged. It can be charged during the charging phase by 63%. So during the discharging phase, if it's discharged by 63%, the remaining percentage will be 37% out of its maximum value. So here from the given, they said that after 2 seconds, at t equal 2 seconds, the voltage across the capacitor is 0.37 E. So the remaining value, I can just write it in this way, 37% out of E. So now we can say that t equal to is 1 tau. Take into consideration the new positive sense. So we must take the new positive sense now, which is against the initial one. Let's start with the given, or the first question in this given. Indicate the direction of the discharge current I. As you know, since this is the positive terminal and this is the negative terminal of the battery, this one will be positively charged and the other side will be negatively charged. So now the current will start flowing in the opposite direction, and we can say that the direction of the current here will be clockwise direction, or from A to D to B, etc. Second part, part B, they said determine the differential equation that governs the variation of UC equal UAB. To find the differential equation, we must use the law of addition of voltages across the circuit. We must start from U, any point. We can start from the capacitor or from the resistor, doesn't matter. Let's start from as a clockwise along the same direction. So we can start from UBA plus UAD plus UDB. All these will add up to 0. There is no battery here at all. So UBA, which is U across the capacitor, UAD is a wire, so this one will be a 0 connecting wire. UDB, which is across the resistor, so this one is RI, and this one will be equal to 0. UBA we must write it as minus UC. Why it's minus UC? Here it's positive, so minus UC plus RI. If I told you what's UAB, since we are starting from the positive to the negative, we can say it's UC. Once I write what's UBA, we will write it's minus UC. It's the opposite of the first way. So the final result will be RI minus UC equals to 0. Now what about I? If we go back to the book, let me just try to directly move to the first page or the first 2 pages of your Everest book. They showed you in this part in chapter 10 RC series circuit okay, here page 193. They will give you the direction of the positive sense and the equation of the current, how to write it, if it's going to be positive plus dq by dt, or if it's going to be negative minus dq by dt. Okay, waiting for the page to be ready. Usually we write I equal dq by dt if the positive sense is entering the plate of the capacitor. So as you can see here, we write I equal dq, if we are talking about plate A, dqa by dt if the positive sense is entering, and if it's leaving, we write it as minus dqa by dt. So if it's leaving, we write it as minus, if it's entering, we write it as plus. Let's check it here. In this exercise, the positive sense is just leaving the positive plate Q. So here this is the positive sense, so it's leaving the plate. So we must write it as negative dq by dt. Let me just recap this part here before I move on to something else. Okay, so just let me repeat this part. The positive sense is moving out of the capacitor, so the current will be minus dq by dt. This is the idea of the current equation. So let me just write here the final result, which is minus UC equals 0. So R times I is minus dq by dt minus UC equals 0. So minus and minus will cancel now. If we multiply all the equation with a minus sign, it will be, and you can just simply reach this result, which is we can substitute instead of Q by C UC. Alright, so the equation will be I equal minus C duc by dt. We know this before, so we can just move and write it in the last form. So I can write R multiplied by minus C duc by dt minus uc equals to 0. The result will be RC duc by dt minus uc, this is the minus sign also, equals to 0. Multiply by our negative sign, it will be plus and plus. Divide by RC, so the equation will be duc by dt plus uc over RC equals to 0. This is the equation for the discharging phase of a capacitor for this equation. They said that the solution of the obtained differential equation is UC equals E into minus T over RC. Deduce the value of C. Simply, we can just substitute the values for UC, and we can substitute the value of E to find the unknown, which is C. So let me write first of all the solution. So UC equals E multiplied by the exponential minus T over RC. UC, which is the voltage across the capacitor. They told us, or they gave us a given, that at t equal 2, it's 0.37 E. So we can just write here 0.37 E equals E into minus t here, it's 2 seconds, over R, we know it, which is 1000, multiplied by C. Here we must do some math calculations, cancel the E's together. The result will be 0.37 equals E into minus 2 over 1000 C. Now next we must just use the ln function. So ln 0.37, you know that using the ln you will cancel out the E, so it will be ln of E to the power this one, it will be minus 2 over 1000 C. Usually ln, let's say ln E to the power A, it will be A, so we just get rid of this one, it will be A ln E, and it's 1. Now just do cross multiplication. This one will go to the denominator, and C to the numerator, it will be minus 2 over 1000 ln 0.37, and the answer here will be 0.002 farad. The capacitance is measured in farad, or we can just write it in millifarads, it's the same. Now they said that in part C, indicate the component that supplies electric energy to the circuit and the one that receives electric energy during the discharging phase. So it's clear that the capacitor is providing energy and the resistor here is receiving the energy. So this one supplies energy during the discharging phase, and this one is receiving or consuming the energy. In part D, the final part, calculate the electric energy stored in the capacitor at t equal 0. We know one formula. Let me just take this part and write it down there. Okay, so to find the energy stored in the capacitor at to find the energy stored in the capacitor at t equals 0, we must use the equation for the energy, which is W equal half C UC squared. At T0, the voltage across the capacitor UC will be maximum. Here we are talking about the discharging phase. So before starting to discharge our capacitor, initially it's fully charged to E. So it's half multiplied by C. The value of C we know the value of C, which is 0.002, and multiplied by E squared, and E it's 80 volts. We can just get 6.4 joules. This is the first part I, and the second part 2I. Determine the average thermal power produced in the circuit during the time interval from 0 to 2 seconds. If we want to talk about the thermal power between this time interval, we will use the same equation, which is, let's write it as WC prime, which is half C UC squared. The value of the capacitance, it's still the same, so it's 0.002, and half will remain. Just the value of the voltage is the one changed. At t equal 2 seconds, we said that this is tau. So the capacitor will be discharged by 63%, the remaining will be 0.37 out of E. So here we just substitute 37 out of E squared, and after substituting the values we can get the energy, which is 0.871 joules. To find the average power, and since they said they need the average power, power is energy over time. Here we are talking about WC prime over delta T. So the value of WC, sorry, here delta E over delta T. So final energy is 0.6. Let's check the final energy. It's 6.4 minus the initial energy, or at T equal 2 seconds, it's going to be 0.87 over the total time taken is 2 minus 0. It's going to be 2, and the value will be 2.76 watt. That's all. Thank you.